let's go ahead and let's get started on this first lab of the day, which is going to take us, we got 30 minutes on the clock. I think that that's a good time, but I want to walk through exactly what you're going to be doing. So if you can bring the full screen in and make me go away. There we go. Awesome. With SYSMON, the first thing that we're going to be doing in this lab is we will be disabling the firewall and disabling the antivirus for this system. We will be shutting both of those down. We will get our IP address because we're going to be compromising the computer system. And then we're going to open up a Kali instance and we are going to mount a remote share. You can see this command, mount TCIFS, your Linux IP address. You're going to put your Linux IP address where it says your Linux IP address. You're going to not have the brackets on either side. It's going to be a straight IP address to get that going. Then you're going to mount it to the mount Windows share. And I'll explain more about what's going on with the Windows share as we progress through it further. Then you're going to CD into that share. You're going to get your Linux IP address. Super important. And then you're going to use MSF Venom to create malware. We did this on the first day with App Locker. I don't know if you all remember that, but we had an App Locker lab where you played with it, and you're going to create that same type of malware again. Then you're going to become root, and you're going to fire off MSF console. You're going to invoke the multi-handler. You're going to set the payload to be Windows Meterpreter reverse TCP, set the lhost to be your Linux IP address. Then you're going to type exploit. And once again, when you type exploit, nothing is going to happen, like at all, like whatsoever. It's going to be kind of boring at that point. So we've got an exploit. Then you're going to CD on their Windows command prompt. Over here, it says start a Windows command prompt. Then you're going to CD into Intro Labs, and you're going to invoke SYSMON. This is going to start the SYSMON logging facility, and we're going to spend a lot of time talking about how awesome this type of logging actually is for an organization that's trying to develop good IR logging capabilities. Then you're going to CD into the top level directory and you're going to start trustme.exe and you're going to get your Meterpreter session. Now, if you all are all good, I will walk through some of the things that you can do with the Meterpreter. Does that sound like fun? When we're done with this lab, we'll run through it. All right, we'll go and do that. That sounds like a good time because it's fun to have fun, but you have to know how. Then you're going to open up Event Viewer. And then you're going to go into Applications and Services Logs, Microsoft Windows, and then you're going to scroll all the way down to SYSMON Operational to open that up. And then you're going to see the event logs, and you're going to see the wonderful data that we get from the event logs whenever we run SYSMON on the system. And that is the lab. And like I said, I will go through this. We will do this slowly in about 30 minutes. I will go through, explain everything step by step by step. And I say we do a little bit of a detour and maybe we dump some password hashes, see what that looks like in SYSMON. Maybe we invoke a keystroke logger and see if SYSMON can see that as well. So a lot of really, really super cool things going on with this lab. As usual, remember to shut off your Windows environment. Actually, your whole lab environment. When you're done with the lab, just destroy it because there's nothing we want to keep there anymore. Just gets in the way, destroy it, and then we'll recreate it for the next session. So we have 30 minutes on the clock. Let's get rolling, everybody. So let's jump over to the screen and let's do the lab here in just a second. Let me share my screen. I got to do resume share. There we go. So we should be able to see the shared screen at the moment. All right, so we're going to get started and we're just going to do the whole SYSMON thing. And then we're going to circle back and we're going to spend some time playing with Metasploit Meterpreter and kind of showing you that and kind of show you how SYSMON can be used to identify all kinds of really, really super cool things that you can see in an attack. So I've already disabled the antivirus on this system by doing set M preferences, or we're disabling real-time monitoring. So that is down for the count. So we have that. The next thing I'm going to do is I'm going to do netsh ADV firewall set all profiles state off. We're going to do that because we want the Linux system to connect right back in. Now, one of the things that I didn't talk about yesterday is I feel a little bit bad, just a little bit, just a hair bad about the fact that you can't, like in the real world, you're never going to have a situation where somebody's just disabling the firewall because the attacker asks them to. It's just not the way things work. However, I'll give you a trade. On Windows environment, many of the different packages you can download from Microsoft Store are unhooked by AMZ, the Microsoft anti-malware service. So if you were to download PowerShell from the Microsoft Store and use that version from the Microsoft Store, many times it's completely unhooked from AMZ. Or if you do the same thing with Python from the Microsoft Store, it is also many times unhooked from the Microsoft anti-malware service. So there you go. There's a little bit of a trade in what we're actually doing. Oops, Java update available. Not today, Satan. All right. So the other thing about this NetSH ADV firewall, set all profiles stayed off. It is very, very common for Windows computer systems, as I mentioned during the app locker lab, where Windows computer systems, once they're in an Active Directory environment, just shut off their firewalls and allow any system to connect in. So we have that. The next thing we're going to do is set that administrator password to password 1234. I'm going to copy that over. I'm just going to do that. There we go. There we have it. That's awesome. And then I'm going to get my Windows IP address, right? I just want that IP address because we're going to be mounting that share over from our Linux computer system over to our Windows computer system. So I'm going to move this off to the side. So I have that IP address of 1010. What is it? 213.155, I think is what it says. All right. So next we're going to go down and we're going to go into our Kali system and we're going to become root. The reason why we're becoming root in our Kali system is because we are mounting a share and doing some Metasploit shenanigans. I call shenanigans. There we go. Next, we're going to mount that share, but I need to get the IP address of my Windows system. So I'm going to grab that whole command right here. We've got the user ID and password there. I'm going to right click, copy that. And then we're just going to paste that in and then we're going to modify it, right? So we're going to modify it to put in the the Windows system's IP address so we can mount that share. There we go. So let's put in the Windows IP address, which is 10.10.213. What is it? Is that 155 or 156? 155. The monitors are so far away from me. There we go. Now we have that share mounted. Now I'm going to CD into the mount Windows share directory. And if I do a Control L and I type ls, you can actually see that we have Windows files. So we've mounted the share on the remote Windows computer system and it's ready to go. Next, we're going to run ifconfig to get our Linux IP address right there. So we're going to right click, copy that, and we're going to paste that in here like so. ifconfig, good stuff there. And next, what we're going to do is we're going to use MSF Venom to generate our malware. All right, we're going to copy that over here. I'm going to move this little Kali window up a little bit so we can see it a little bit better. There we go. So Control L, there we go. We're going to paste that in. And then I have to get my Linux IP address. Oops. Put that in there. And that IP address is 1010 something something. A little something something. And 10 dot, let me scroll up just a hair. 10.10.224.50. I hope I got that right. Let's just double check that because that's a good idea. 10.10.224.50. Yep, that looks good. And then we're going to hit enter and we're going to create that malware, the same type of thing we did in AppLocker. And it's saving that malware over into the Windows computer system under Mount Windows Share under the C drive. And we will run it here in just a couple of seconds. So while that's cooking, let's kind of redo what this command does. Let's kind of refresh what this is actually working on here. So we have the A is the architecture, and the architecture is going to be a 32-bit architecture. It's going to be a 32-bit architecture on the Windows platform, right? And we're going to give it the payload of Windows Meterpreter reverse TCP, because once again, when that executes, we want that system to make a reverse connection back to us. We're going to specify the L host is 10.10.224.50. That is the Linux system's IP address. The L port is 4444. The output file format is executable, and the output file name is going to be trustme.exe on the Windows system. Next, we're going to run MSF console. We're going to run MSF console Q for quiet. Quiet, because I am sleeping in here. All right, so we're kicking that out right now. And this is going to set up the C2 server, right? We're going to set it up so that command and control server is receiving that connection whenever we invoke the Meterpreter reverse TCP. So I want you to think this through. See if you remember the App Locker lab. What was the name, like the name of the raw executable that MSF Venom put its malware into? Do you remember that? While this is loading, I'm asking some questions for you. Do you remember? What was it? Yeah, it was ab.exe. It was ab.exe. And remember, up here with MSF Venom, we can do a T minus T and give it an alternate template executable for it to insert its malware, so we can get away from ab.exe. If you want to have some fun, you can find that template and you can upload it to VirusTotal and see how many AV engines detected. All right, so we've got our Meterpreter session is up and running, so that's good. I'm already root, started MSF console. We're going to use exploit multi-handler, right? We're going to set up that multiple operating system handler to handle the reverse connections coming in to the computer system. Next, we're going to set our payload to be Windows Meterpreter reverse TCP. So again, that setup in MSF console is the same as our malware up above. We make sure that those two things tie together. Allows them to hang together like a nice rug in a room. We're going to set the L host to be our Linux IP address here. We're going to put in that IP address, which is 10.10.224. Put that in 10.10.224.50. That is our Linux IP address, because it's going to be expecting these reverse connections to come in, and it's going to try to set up the multi-handler on this system. And then we just type exploit, right? We're just going to type exploit on that system and nothing is going to happen. You're just going to see it starting handler on 10.10.224.50 on port 4444, which is the default port on our Linux system's multi-handler coming back from Metasploit. And you can change that port to be anything you want it to be. You can even change the underlying protocols that the malware is using as well. Next, we're going to open up a command prompt, and we're going to start up SYSMON on our system. We're going to cd into intro labs, like so. Copy that. There we go. So we cd into intro labs, and now we're going to start SYSMON. And we're going to give it a config. And I want to spend a couple of seconds. We're using the default Swift on security config right now, but there are other configs that one can use. And I'm going to talk about Olaf Hartog here in just a second. Copy that. I'm going to paste that in like so. And now SYSMON is running. All right, so life is good. So let's talk about that config for just a couple of moments. So SYSMON Swift on security is pretty good, but there's also SYSMON modular. And SYSMON modular does a number of really, really super cool things. The first thing is you can actually go through and create your own SYSMON config. There are some default configs that are really, really solid down here, where we can have the default balance configuration, most used, more information is here. We can look at what that has. Just by clicking on here. I'll come back to that here in a second. And we have verbose, MDE alignment, super verbose. All of those are available to you as well. Now, when we look at the configuration option, you can create your own custom configs with SYSMON modular. And this is truly where the power of SYSMON modular comes in. If you're missing something, you can easily change this config on the fly to add in the things that are required for you to be successful in actually detecting attacks in an environment, which is pretty super duper cool. Now, Why is this super cool? Well, this is super cool because we can then use additional tools. Like if we look at active countermeasures, we go to active countermeasures and we go to our free tools. We have some really cool tools, and one of those tools that we have is SB. Now, SB allows you to go through and use SYSMON network configurations, where we're getting SYSMON event ID 3 connections, so we can see what is the network connection associated with it. And we can incorporate that idea into AC Hunter. We can incorporate it into Rita. Because one of the questions that was asked, that I get asked all the time actually, is if we're using something like SYSMON, can we actually look at the network connections? Now, the Swift on security config that we use for this lab doesn't have that config, but with Olaf Hartog's, we have the capability to change that out on the fly for us so we can see those network connections, which is pretty cool. But even without the network connections, we got some cool stuff that I'm going to show you that SYSMON provides as well. So now I'm going to CD into the intro labs directory. And then we are going to, oh no, I don't need CD into intro labs. I'm going to CD into the top level directory, and we're going to run trustme.exe. So we're going to execute the malware on the other side, and now we have malware that is fully executed over here on our Windows computer system. Now I'm going to start the event viewer, and we're going to take a look at what SYSMON shows us with the SYSMON config from Swift on security, and what are the things that we're getting at. So I'm going to select applications and services. We're going to expand that out. Takes a few seconds for it to load. Why? I honestly don't know. But do remember that we're running systems kind of lightweight in the cloud on this. So get that to expand. Then we're going to go to Microsoft right here. Then we're going to go to Windows right here. And then we're going to scroll all the way down to SYSMON. SYSMON right there. And we're going to choose operational. All right. And this is going to open up our SYSMON logs. Now, if we look at these SYSMON logs, we have a number of different things that we're firing here, right? We can see that we started up the event viewer MMC. We can see that here's our malware right here, right away. And we'll look at some additional things. So this, you can see ab.exe, the Apache HTTP server. The command line is trustme.exe. And yes, my Zoom is doing weird things today on Zoom. We could see who actually executed this as well. So we're getting some really powerful data right out of the gate with that SYSMON information. So now let's do some stuff, right? Let's actually go through and do some things on our system, and let's see if SYSMON actually detects it. The first thing I'm going to do is I'm going to run hash dump. All right. So this allows me to dump the password hashes from the Windows computer system. You can see that we have the password hash here for the administrator account, the default guest account. Notice that all of the password hashes go through quick what you see here. So the RID is the unique identifier for the user account. Administrator is always 500. Even if you rename it to something else, it's still going to have an RID of 500. We have this AAD B3 B4 35 D5 1404. That is the hash of padding. That is a blank landman password hash. And notice it repeats. That's because the landman hash is two separate hashes, 7 character strings each, both of which are blank. And you can see that it's a repeating string of characters. Then we have the NT password hash there, and they're separated by a colon. So we were able to dump the password hashes. Did SYSMON detect it? So let's go ahead and let's refresh that really quick. And let's see if it actually detected that. So now if I go up in this as well, let's see what we got here. We got update, trustme.exe. Ooh, look at this. Now we're getting rules. It says remote threat detected, right? Remote threat detected, or remote thread detected. And specifically, let me zoom in on this, even with the weird zoom, it's awesome. It says that we had trustme.exe invoked the local security authority subsystem service. Sorry, my eyes are going really bad. I need to get some eye drops or just be younger. So we can see create remote thread has been detected. You can see that trustme.exe invoked invoked local security authority subsystem service. And that is how Metasploit Meterpreter injects itself into a running process to pull down the password hashes. So those password hashes exist inside of LSASS. Anytime you try to access account, automatically the system will load those password hashes up into LSASS. So that's really, really super cool. Let's try another one. Let me go Control L, and let's do key scan underscore start. I don't know if this one's going to work. We'll see. So let's go ahead and let's run that. And let's go ahead. I'm going to select that one of interest here. We got it, remote thread detected. And let's go ahead and refresh and see if it got anything at all with us doing a keystroke logger. I kind of don't think it did, actually, because we should see a remote thread detected, but that time invoking inside of explorer.exe. So we didn't get that. We got no new SYSMON events for someone running a keystroke logger. All right. So cool. What else can we do? One of the ways that you can get a shell on a Meterpreter session, we can ls out files, we can ps the executables. We have a number of different things that we can do. But one of the things that you can do is run shell. Now, with that shell, we should see an event where shell is spawned over here. So let's go ahead and refresh that. And there you can see cmd.exe was ran by administrator. See, if I zoom in on that, you can see a command prompt was invoked. You can see that the parent process image was trustme.exe. Really, really just super cool stuff. We're actually seeing that process execution on this system. So did it detect anything else that I did? That's WPAD. That has nothing to do with anything. Edge update has nothing to do with anything. And then we're back to LSASS. So I was able to detect the shell on that system. I can also run, let's say, let's run a hacker command. Let's do net use, we'll do star, and then we'll do //127.0.0.0.1. And we're just going to go ahead and mount the C drive on myself. So now I have a Z drive mounted. It's just myself on myself. It's this recursive loop where I mounted a share. Let's see if SYSMON actually detected that, right? So we can go ahead and do refresh on that. And you can see, sure enough, here is the net command, right? Oops, too far. Now I've gone too far. So you can see the net command was invoked by administrator. And if I scroll down, you're able to see that the parent process associated with this was Windows on Windows cmd.exe. So we can see that process ID for the command prompt. But if we go back to that command prompt, you're going to be able to see that process ID parent is trustme.exe. So it allows us to kind of pull these things back we can now see what's going on. Now, let's do a comparison, right? So if we're playing with SYSMON, let's just do a quick comparison. And let's see if we had any of that level of fidelity in the security, the application, and the system event logs up top, right? So if we go through and we scroll all the way up, right, to our main Windows logs, if we select those, if I go into, let's just do application because I started a bunch of applications, right? Are we going to see any of that, right? Are we going to see any of that level of fidelity? Successful auto update, successful auto property update, root certificate, update root certificate, desktop Windows Manager is registered to the system port. A service stopped. That's fun. All right. Scheduled service software protection. That's nice that that is running. I think it's good for everybody that that is running. DB engine. We talked about this yesterday. I'm not seeing a lot here, folks. Right? But maybe it's in the security event logs, right? Because security event logs are really, it's going to have security relevant stuff. So I can zoom in on that and we can go through these. We can see that somebody logged into the system. We can see that I accessed the event logger. That's kind of it, folks. Oh, Nope. No. We can see somebody logged in. Now, this one is useful, just for the record. The computer attempted to validate the credentials for an account authentication package, and it says the account is administrator and the source workstation was Kali. I think we can all agree that if you have a system in your environment that's logging into any other computers in your environment with the name of Kali, that's probably bad, right? That's probably not a good thing, honestly. So yeah, we've got that going. So yeah, we've got a bunch of cool things that we're now getting with our logs with SYSMON that we're pulling out of the computer. And I absolutely love this lab and what it actually shows. All right. So editors and students kind of break, and I've got a few minutes. We can answer some questions. Does anybody have any questions on this as well? Question, I wonder, do we have a process tree viewer that's based on the logs instead of the usual that's based on real time? Yes, dprompt. You can use PS tree, but you can do that. I would recommend dumping the memory off of system that is suspect and then doing an analysis utilizing a tool called volatility to analyze that computer system's memory. And if you would like to take a look at a lab with that, we actually have a lab over here called volatility that shows you that full process hierarchy. Where is it? Is it down here? It should be, I'm missing it. Memory analysis right here with volatility. You can select that and that'll walk through how you can pull down that process hierarchy of what process actually detected it. The other thing that you can do is you can run WMIC, where you can pull the process ID where the process ID is the main process ID of interest, and you can pull the parent process ID information, and that is right here. WMIC process, get name, parent process ID, select string, put in the process ID in question, and you can pull that through WMI as well. So we have lots of labs and lots of things for you to play around with. So check that out, and that should be available to you as well. Does the event ID found in SYSMON align with the list of events you said we should look at earlier? Those are different category of event IDs. Those are like domain controller. Those are like the main 6 event IDs for looking at authentication events in Active Directory. So when we're looking at SYSMON, they're different event IDs. You know, like 22 is DNS lookup, 3 is a network connection, 1 is a process execution as well. So very, very cool on that as well. What considerations should we have regarding how much space SYSMON logs will inevitably take up? I mean, typically it depends on your config, right? So I'd recommend setting up Olaf Hartog SYSMON modular and seeing how much it generates. But once again, if we're looking at this, we're now looking at something that provides value, and you don't need to be pulling the application and the security event logs necessarily, or the application event logs. You're going to get a lot more value. And also Olaf Hartog SYSMON modular has the capability for you to, it basically puts a tag in there of what MITRE attack technique matrix is matched when you have a hit. So it can do that already. May need to update the WMIC lab. It was deprecated and they're not adding it to Windows 11. Circumstance in PowerShell. I'll take a look at that. It's weird that Microsoft would actually completely get rid of anything. So WMI is not there at all. I can check. I think I've got a Windows 11 system here. Let me check something real quick. Let me go to CMD. Run as administrator. Where did my command prompt go? Oh, it's over here on that screen. Let me put it up over here. Nope. Seems like it's working. WMIC process list full. And yep, it seems to be working just fine on my Windows 11 system. But it's not uncommon. WMI, Windows Management Instrumentation, is still going to be available within PowerShell. It's just whether or not it's actually going through and going to be its own separate command, because a lot of those things are still going to be exposed. Yeah, I don't know. I can check. I can check as well. But yeah, we may be updating the lab. Not a big deal. But it also still exists on Windows Server 2022 as well. So we'll take a look at it. But no, it's funny. There's the deprecation timeline. It's funny. Windows WMIC is deprecated on server OS in 2016, and we're on a 2022 system, and it's working. Yep, I'll have to check on it though. Maybe it's missing on 2025. But yeah, we can update all of that and just use PowerShell instead, because PowerShell can invoke all of those different WMI commands. So we'll be sure to update that. I think at minimum, we should add it, right? Because you should never remove it completely, because not everybody is at the most recent operating system. And we'll probably keep them both for a period of time, just so people can see them both run. But thanks for the heads up on that. Yeah, you're going to need both. It helps for a while. All right. So let's go ahead and we're going to push the break just a hair today because we had a long lab, and we're going to move into yet another lab here in just a moment. So I want to get this set up, and then we're going to do a lab and a break. Okay. Let's go into slideshow. No, thanks. I don't need that, Microsoft. I don't need you to tell me how to do PowerPoint slides. All right, here we go. So let's talk a little bit about advanced endpoint protection. All right. So once again, if we're looking at the MITRE attack technique matrix, we're really focusing on initial access and persistence most of the time, right? Like we're going to be focusing on that initial access and persistence side of it. A lot of these other things like discovery, lateral movement, many EDRs can detect that as well. But when we're starting to get off of the endpoint and doing things kind of across the entire environment, I generally like to be using a variety of different tools at that point. Network detection and response tools. I like to be using, EDR. I like to be using SIM, because there's no one tool that actually detects all of the different attacks that are out there as well. And this is really building us up to one of the key points of this class. And honestly, I should have this one of my starting slides: overlapping fields of visibility. All right, overlapping fields of visibility. When we're looking at protecting an asset, let's just say an endpoint, what are all the different things that are protecting that particular asset? We have AV, we have network security monitoring, we have a SIM, we have UEBA, user entity behavioral analytics, are all protecting that asset. And they're looking at that asset in a variety of different ways, right? Like they're looking at it from an AV perspective. They're looking at it on a network perspective. And the beautiful thing about this is if one of these things is actually missing, then it means that there's three other things to help protect that asset, right? Because any one of these things that are listed can in fact be compromised, can in fact be bypassed. I don't know of a lot of attackers out there, even at the elite nation state level, that can bypass every single one of these things. Usually most nation state level adversaries, and trust me, I know, I've trained people at the NSA. I have an idea of what their capabilities are because I've worked with and trained them, and I've done hot nation state on nation state activities in the past. And yes, they absolutely have techniques to bypass AV. They have techniques to hide on the network. They have techniques to try to hide from event logging, and they have techniques to try to deal with UEBA. But they don't really have a lot of techniques where every single one of these things exist and are working in conjunction with each other. And when I was working and doing offensive stuff for the United States government, if we ever got into an environment that had this level of telemetry that you're actually seeing here, we would basically go to a commanding officer. Once again, I was not in military. I've never worn the uniform, and I don't want to say that I have, but yes, I did work in the intelligence community. And we would go to the commanding officer and we would say, hey, we're in an environment and the likelihood of us being detected is high. And it would be up to the commanding officer to decide whether or not the mission was critical enough to move forward, or whether or not we wanted to back out, slow down, and try to wait or do something else. And the decision of a commanding officer usually depended on what they were doing. If you were working with something like the NSA, they would say, hey, we're going to back out, we're going to move slow. We don't want to set up any alarms because any of the techniques that we would be using could possibly be burnt, and all of those techniques have a legitimate cost associated with them. However, if you're working with like on the ground DoD, you're working downrange, you're working with JSOC or SOCOM, many times those missions were so critical that we would absolutely proceed at risk with a higher chance of detection, or we'd bring other techniques to bear. But most of the time for general nation state level stuff, if you get into an environment that has this stuff set up, you're going to back off. And I'm telling you this because it is absolutely important and essential for all of you to understand that even at the nation state level, when you have these many things, and I could throw in cyber deception in this as well, if you have all of these things at play, a lot of times nation state level adversaries will move on to something else or try a different approach. When you're looking at ransomware attacks, when you're looking at general hacks that are happening, we see it all the time where we have an environment that has this level of telemetry in it, and they have maybe a workstation that gets compromised, and then they very quickly respond and deal with it because they have multiple overlapping fields of visibility. The other problem that you have with this, though, with CIOs and CTOs is they'll say, oh my God, we have 4 things protecting the endpoint. We are, quote unquote, wasting money because we have multiple tools doing the exact same thing. And that approach is stupid. We've been talking about defense in depth since the 90s, and defense in depth has nothing to do with the amount of money that you spend. It has to do with the overlapping fields of visibility in your environment for your security. Also, when you're looking at Venn diagrams, right? If you have like areas and you have 2 circles in a Venn diagram and they do not overlap, that means that there's an additive effect of computer security. Whenever you have them overlapping, it's multiplicative, multiple things. Yes, multiple things. Use the X, right? X going to give, or a star, whatever. But you're going to use multipliers to look at this. So when you're talking about like analyzing and looking at data, when you have overlapping Venn diagrams, it is a multiplier, a force multiplier in your overall security. So keep that in mind. So when you're looking at these products, you need to get ready to pay. Right? There are some products out there that are free and open source that are pretty good. If you remember, we talked about, WhatsApp, which is a great tool. Once again, you're required by law. Every single time you refer to WhatsApp, you got to refer to it like the Bud Light commercial in the Super Bowl, right? Have to, right? By the way, the people that make that tool love it when you do that. Telling you, right? So traditional denialist and AV is pretty much garbage. With advanced endpoint protection, we have much better tools. This isn't just an incremental increase in security, it's a quantum leap in security. And there's lots of products out there. Now, with artificial intelligence on the game, this gets into something, I don't know, it depends on how you want to look at it. You could totally look at it as depressing. But when you're looking at artificial intelligence is only as good as the data that's being fed to it. And which vendor out there has the most telemetry and data being fed through their security products? Think about it for a couple of seconds. Jot some ideas down. There's one vendor that's going to come right to the tippy top, and that vendor is Microsoft by far. Right? So when you're looking at a lot of these vendors, if you're looking at something like CrowdStrike or you're looking at a Microsoft, they're getting naturally more telemetry than some of the other vendors that are listed here. SentinelOne is in a lot of MSPs as well. So if you ever have an EDR that comes up and they're like, we're a small niche EDR and we're doing something new, it's very hard for them to actually compete at scale on that as well. And we just had it confirmed on Windows 11 24H2 in that particular VM. It does not have WMI. So remember, you're going to have to know WMI, and you're probably going to have to learn some PowerShell commandlets as well. And we will update the class as these things progress. All right. So Bluespawn and EDR, like kind of an EDR stand-in for what we're going to be dealing with. So how do we actually evaluate our EDR products, right? And this is just a tool that's going to stand up and pretend to be an EDR because I can't give you a full commercial EDR in this lab. Believe me, I've tried. I've tried giving the students full licenses of Elastic for 60 to 90-day evals, and we tip over Elastic's front end, like their commercial front end, like registration breaks. We tried doing this with Lima Charlie. Same thing. So it's really, really tough to create a lab where we have the Antisyphon BHIS hug of death, where we bring their entire environment down. If you want to know how bad the hug of death is, we had a lab where we had, I think it was like 2,000-3,000 people using GitHub and pulling the exact same file at the exact same time. And we actually crashed GitHub in the United States for a few moments, which I was pretty proud of that. I'm not happy about bad things happening, but it's good to know that we're making a difference in life. Right? Now, Bluespawn, as I said, is not meant to be a full commercial EDR. If you're looking at the coverage that's provided here, it's not 100% at all, but it is really good from an open source perspective to do some level of detection on different attack methodologies. So let's go through and let's do a lab using Bluespawn, and we're going to be using a wonderful little tool called Atomic Red Team for this lab. So let's go ahead and let's go to our labs here. We're going to be running, I think it's Atomic Red Team. Oh, it's Intro to SOC. I need to go to Intro to Security. We're going to do Atomic Red Team and Bluespawn. So like I said, with this lab, the goal of this lab is not for you to like say Bluespawn is the tool that you should be using, right? We're going to start up Bluespawn. It's going to do some cursory level detection. And then we're going to be like running Atomic Red Team. We're going to be downloading the atomics and running Atomic Red Team. And we're going to be trying specific techniques. And we're going to be seeing how Bluespawn reacts to those techniques and whether or not it actually detects them. All right. So this is the lab that we're going to be doing. And with this lab and the fact that I pushed you past the break, I'm going to give you all 45 minutes because at the bottom of this lab, it says you can totally exploit the system again with Metasploit, get shell, and try to do some one-off techniques on this system as well. And I'm going to walk through that when we get there. So we're going to be doing the Atomic Red Team. We're going to be doing the Bluespawn with it. So we're going to do this lab and we're going to give you, let's just say, let's do 45 minutes for break and for lab. So go ahead and start the clock and then I will do the walkthrough and we will move on to, I think we're going to be doing firewalls here in a little bit, but the walkthrough is going to take me a while because there's a lot of really important things that we're going to discuss in this particular session. All right. So we will see you on the other side of the lab. Okay, so I have here the first edition of the Future Is comic book. And I'm really excited about this. We just got these on a pallet. Oh, listen to that. Hear that? It's good. Brand spanking new. First edition. And it's flipping gorgeous. Just very, very, very cool. So if you're so interested, you can go to Recop Publishing and you can check out Future Is, or you can help me out. You can go to your local comic book store and ask them if they have Future Is. It is part of Lunar Distributing for comic books as well. Oh my God, it smells just like a really good comic book store. That's a great comic. So check that out. We got some cool stuff. But you know what else we have? I'm going to switch into John teaching mode. Actually, it's over here. We're going to be jumping into the lab. So let's get right into the lab and let's get rolling. While we were on break, I went through and I installed the Atomic Red Team just because it takes a little while. But we're going to start at the very beginning because it's a very good place to start. And it says set MP preferences, disable real-time monitoring to true. So I'm going to do that again because it seems like Microsoft Windows Defender has a way of popping up and running on your computer systems, right? We saw that. And then I noticed when I was looking at tech support while I was on break, it says open a command prompt. So there's a number of ways that you can open a command prompt. You can open a command prompt directly. You can open a command prompt from the bottom, but you have to be in a command prompt, not in PowerShell. So we're going to go ahead and open up a command prompt. The other ways worked too. You could just do command prompt and you can right click and you can run it as administrator. Works just fine. Gets you the same thing. We just have a quick link to it, but you have to be in a command prompt. And you can tell the difference because in the screenshots, it says here is C right here, C prompt. And then anytime we're in PowerShell, it's PS C drive. So there is a difference in the way that those things look as well. So whenever we do that, we're going to CD into the intro labs and we are going to start Bluespawn. All right, let's go ahead and start that. Now, once again, Bluespawn is not here to be like, you all need to use Bluespawn. It's already getting a little long in the teeth. It's getting pretty old. It still works really well for what we're doing here, but it's really meant to just be a utility that we have in this class to help you understand how we can do adversarial emulation in your environment to make sure that we can detect a variety of attacks. So it's hooking in the system. It's going to start up a bunch of different checks for detecting exploitation, post-exploitation, service creation, port monitors, accessibility feature exploitation techniques. It's basically going to start the ability to detect all of that stuff right there on our system. So we have our PowerShell up and running, and I have already gone through and I've installed PowerShell with Atomic Red Team. So I have that ready to go, and I just did that. Kind of a little bit cheating, doing the Julia Childs thing. She's like, "Oh, look at that, the cake is done." So that cake is cooked just because it takes a while for it to download from GitHub. Well, the day went really, really fast for me. I was pretty happy with that. I'm going to CD into the Atomic Red Team, invoke Atomic Red Team directory. And then I'm going to import a module, PowerShell YAML. So PowerShell can handle yet another markup language. I'm going to put that in there. And then we're going to actually start running some different modules in Atomic Red Team. So with Atomic Red Team, there's a couple of different ways that you can go about doing this. You can do this as invoke all, where it just invokes absolutely everything. Or you can invoke each individual atomic test by itself. And they break them down into categories like T1547.004, as in there's multiple different ways to do that specific technique. And it's broken out that way. So we're going through and we're going to invoke 4 of these so you can see what it actually looks like whenever these run properly on a system, and really checking to see whether or not the EDR can actually detect it, whether or not Bluespawn is able to detect it. So we'll invoke that test, and then we'll walk over here, and you can see, sure enough, it can see that we tried to invoke win logon helper. Now, right off the gate, if we're looking at Bluespawn, sometimes it jumps right up and it's like, here is the actual detection that we were able to detect, right? We were able to detect this category of win logon helper, DLL, it's cursory, and we were able to find 8 specific detections of that being used. Now, what is that? Why is it important? Well, when we're looking at detects, we're not just saying, hey, are we able to detect a specific string of a specific attack? And that's exactly what this is saying right here. We saw this category of attack, and we had 8 complete signature match detections of someone trying to invoke cmd.exe via Explorer, user init, registry key settings. It was able to detect 8 of those different techniques explicitly. If, however, I scroll down, you can see that there's some additional things it's throwing, and it's saying masquerading, cursory, 0 detections. What it's saying is it saw something that looks similar to masquerading, but it didn't match a highly specific string on that computer system. So that is the differences between those two. One is saying I matched a very explicit attack string, and the other one is saying I saw something that could be that category, but I saw nothing that matched an explicit attack string. You actually see this quite a bit in AV EDR products as well. If it sees a full matched string, it basically throws a massive error and it becomes a critical or a high level alert. When it sees something on the system that could be like registry key modification or some weird PowerShell shenanigans, it's basically usually a medium level alert. It's not something that rises to the level of needing to be analyzed and dealt with like right effing now. It's usually set up as something that you could investigate. But most of the time, what we find in Black Hills Information Security is the overwhelming number of organizations don't bother investigating these at all. It doesn't make it to their dashboard, doesn't make it into their alerting and telemetry. It doesn't do anything whatsoever because it never makes it to the analysis ticketing queue. And there's some good reasons and some bad reasons for that. I mean, the security professional in me is like, you should investigate and chase down every single one of these. But your actual team of SOC analysts is going to be constantly chasing their own tail after these things. There has to be some level of automated triage within these things. So just keep that in mind. So the next one we're going to invoke, let's see if it actually detected that one. Give it a couple of seconds. And you can see that we can see group policy modifications. We're monitoring and dealing with services, but it didn't match a very specific string. All right. So the one up above, we had very cleanly matched signature strings, but the one below, it saw something, but it doesn't necessarily rise to the level of being, this is something that needs to be investigated immediately. So what's the next one? We got invoke atomic test. Do that one. Copy. We can paste it in. There we go. All right. Once again, did we get anything in Bluespawn? Nope. Oh, there we go. Yeah, we got a lot. Okay, once it got to the end, it lit up like a Christmas tree. Really, really, really fast, right? So yeah, we got a bunch of stuff with that one. And then the next one down is, we got T1546. Let's go ahead and give that one a shot. See what it does. There we go. Let's see if this one trips any alerts. It absolutely does. All right, so what do we make of all of this, right? You're not going to be in a situation where every single one of the detects that like Atomic Red Team is doing, it is almost impossible to have absolute complete detection all the way through, right? But when you're trying to deal with the MITRE attack technique matrix, as we're doing with Atomic Red Team and invoking the different tests and seeing how that correlates back to an EDR, when you're doing all of that, it is important to know that you probably can't get 100% coverage, but if you can get enough coverage, the attacker is eventually going to step into a landmine and they're going to detonate. You do want to make sure that you have really good, solid coverage across as many techniques as possible, but you don't have to get into, well, we got to be able to 100% detect every single technique that's out there. So this is helpful whenever we're looking at trying to detect attacks, we're trying to do gap analysis, and we're trying to work with management to see what they can actually, fund us for, because that gap analysis shows them this is what's working, this isn't what's working, this is what's missing. And then this is the specific money, time, effort that's required to address that specific gap in our environment. Now, the other thing about this that I think is absolutely essential is what do you do in an environment where you do not have a specific Atomic Red Team test, right? So how do we do testing in that environment where there's something that is out there, but Atomic Red Team doesn't have anything to detect that something? How do we deal with that, right? So here I've got my Kali instance. I don't know why it's not letting me click in. There we go. And I'm going to change my settings. We're going to go in and we're going to change appearance. We're going to change appearance. We're going to change the font. And once again, we're going to open that font up to like size 18 font and change it so it's bold, yet crisp, cool, and refreshing. There we go. So go ahead and go to 18. Nope, that's 16. We want 18, and we're going to select bold. Click okie dokie. There we go. All right. And now I'm going to open up the instructions here for us to go through and exploit this system. And we're going to see what types of things we can detect with Bluespawn on that, right? So I'm going to go down and I'm just going to choose the SYSMON lab, and we're going to quickly go through the exact same steps. I'm going to still disable my antivirus because it seems like the Windows system is getting a little bit spunky today and trying to restart those AV engines on our class system. So I'm just going to follow the instructions. We're going to set our firewall to off. I'm going to disable that. Okay, we'll set that to off. Very good. And you can see Bluespawn is freaking out in the background. Even while we're doing these things, Bluespawn is running into issues. And it's like, there's some really uncomfortable things going on this computer. Firewalls are being disabled and users' passwords are going to be set to password 1234. Feeling a little bit uncomfortable here, which is fine. By the way, I discovered Bluespawn because I had a number of pen testers. Two of the best pen testers I know were working for me at the time. We had Egypt and Mubix. If you know Mubix from Hack 5, he was here at that time, and they were at a CCDC competition. And they were running against the University of Virginia, and the team was using Bluespawn. They had written Bluespawn because the rules were you weren't allowed to bring AV in, and they asked if they could write their own antivirus. And the people that were running the competition were like, goofy kids, go ahead and bring your own antivirus in. And they did. And this is what they created. And it actually was good enough to shut down some of the best pen testers I know. Because once again, it isn't about being 100% coverage. It's about basically making sure you have enough coverage in your environment. And if you're wondering what I'm doing here, I'm not talking this through too much because we've already talked this through in the SYSMON lab and also in the App Blocker lab. We've done this before. So we're not really going to get too terribly crazy trying to re-explain absolutely everything. But the goal of what we're trying to do here is, what if we have something that isn't in Atomic Red Team? What are the different detects and what are the different attacks that we can do? And what are the tools that we can use that are at our disposal that allow us to detect these attacks, or be able to test to see if we can detect these attacks, right? So we're going to CD into Windows, mounted share. There we go. And then we're going to create our malware, really quickly going through this. And we're going to set that up, put in my Linux IP address. Just went off the top of my screen. A little bit of a bummer on that, but that's okay. We can pull it down. But it's going to be 10.10.251.30. There we go. Setting that up for a reverse connection. Takes a few moments for that to come up, and then we're going to run MSF console -Q. Right. And while that's loading, I can talk a little bit about what would be a use case for this that you would run into in an environment while that's working. All right, so let's say CISA comes out with an alert, right? So if we go to CISA alerts, right? CISA has all these like alerts and advisories, and many times they'll talk about these different types of threat actors and what techniques the threat actors are actually using. Now, for the record, I am really not a fan of trying to establish your defenses around what are the specific techniques that a very specific adversary is using at this specific time. And the main reason why I hate that is because it's not true. If we use the analogy of the blind philosophers and the elephant, if you have 5 blind philosophers and they're all touching an elephant in different parts, then all of these philosophers are going to be 100% convinced that they're describing the elephant with absolute certainty in what the elephant is, right? One's going to be describing the trunk, one's going to be describing the tusk, one's going to be describing the feet, and they're all going to be completely convinced, and they're all correct but wrong at the exact same time. So when you see CISA, when you see Verizon, when you see Mandiant, when you see these people talking about threat actors, they are literally blind philosophers describing a part of a threat actor that they have encountered. Be careful in thinking that those are the only techniques that an attacker would actually use in breaking into an environment. But there is value to that, right? Because if you have these particular techniques and the different threat actors and what they're doing, you can see this with CISA, but you can also go to the MITRE attack technique matrix. I go to the MITRE attack framework. We go to the enterprise matrix. You can actually go to, let's go to the enterprise matrix and kind of go from there. So if we choose a technique, right, let's do a bits job. They have procedural examples on how this actually works. And then they actually have who are the threat actors that use this as well, right? So you can go into what are the threat actors that are using this, and you can get a list of the different techniques that threat actors are using, or you can get a CISA alert that gives you what are the techniques that threat actors are using. And then you can start to go through and develop a customized testing strategy for that, Why? Why would you go through the effort of doing this, even though I'm like, this is stupid, don't do this? From a technical perspective, it is. I genuinely believe it is dumb to try to go through and make sure that you have detects for absolutely every single one of the techniques that has been described by a blind philosopher for a threat actor. But politically, there is a tremendous amount of value in doing this. Because if you're trying to do full coverage and you're trying to go through and try to get funding for a whole bunch of different things, it is really, really common for executives to get overwhelmed with the amount of money and different things that you're asking for. And it literally looks like this bottomless pit of cash that you're asking for. And there's very little, they feel like they're out of control in what they're doing in trying to defend the environment and the levers that they have that they can pull. So while you're infinitely going down the MITRE attack technique matrix and you're trying to deal with all of these things, what is it? 10.10.251.30. Having a narrative and a story is a lot more powerful. All right. Having a narrative and that story is a lot more powerful technique to basically get people to release funding. Because if you have a technique in your environment and your environment cannot detect it is one thing. But if I can sit down and I can talk to my administrators, my CISO, my CTO, and all of these people, and they say, here's the actual attacker that is using this, all of a sudden, this is real, right? It's actually a real attacker that's running things against your environment at a specific time on this as well. So there we go. We got a command shell session 1. It's closed. What? Did I do the reverse? Oh my God, I forgot a step. While I was talking. Who would have thought that me constantly talking while trying to do a lab would lead to me not doing something correctly? So I got to set the payload to Windows reverse TCP. There we go. Now let's type exploit. There we go. Now we're going to rerun trustme.exe. Trustme.exe may just fire on its own because once you start the malware, it keeps beaconing trying to reestablish a connection. So we'll see if it actually comes up and pulls it. There we go. All right, so now we got our session over here. So let's say something in Atomic Red Team, we don't have a test for it. And we don't have any capability of any different BAS tools to test for it. We can use Metasploit Meterpreter, and we can use Metasploit Meterpreter to recreate and do that adversarial emulation on the fly to be able to do that testing in our environment. So if we go over here and we go to the Atomic Red Team and Bluespawn lab, and I scroll all the way down at the bottom, I have some things that you can try to check and you can see if it can detect it, right? So with this, we're going to do some registry key persistence techniques, and we can see if Bluespawn is able to detect that, right? So I can fire that off on the system, and we can see, did Bluespawn actually detect it? No, it didn't, right? So that means I have a detection gap in my environment. So now I know that I need to be able to write some type of signature to be able to detect those types of registry keys that are being added into the environment. So this allows you to, yes, do that one is a different one. There we go. And this one does work, right? So this allows us to do that gap analysis. And once again, if you can actually tie that back to a specific threat actor, to a specific CISA alert, to a specific MITRE attack group that has been identified, then you're not just making up all of these different things and saying, well, you know, attackers may be able to do X, Y, and Z. You're able to say explicitly that attackers are doing X, Y, and Z and ABC 1, 2, 3. Yeah, you know me, in the real world, right? So I'm going to go ahead and I'm going to destroy my lab because we did bad things to that particular lab. We did a lot of bad things. A lot of bad things we'll be wishing on this because you don't want to piss off Kendrick Lamar. That would be bad. That would be a bad thing that somebody would be wishing on you. Yeah, we're going to reference the Kendrick Lamar and Drake. Is it even a battle at this point? Seriously, I mean, I think Kendrick Lamar won that. I think everyone can agree that Kendrick Lamar has won that particular battle. All right. So let's go ahead and let's finish talking about threat emulation. And then we're going to get to our last lab of the day. We're going to be playing around with firewalls. I'm going to give you guys a little bit of a challenge to try to deal with something, to try to troubleshoot what is going on. It's a fun little port scan challenge on that. So when we're looking at threat emulation, we're using things like Atomic Red Team. We really shouldn't look at vulnerabilities as just something as simple as missing patches on a computer system. You just shouldn't be dealing with it. Now, we need to be looking at that post-exploitation aspect of it, right? When you have the post-exploitation aspect of that, you're now at the point where you're starting to fill out the MITRE attack technique matrix. You're starting to fill out what it is we should be doing and should be detecting in environments it should have been doing for a long time, right? When you look at standard vulnerability assessment and vulnerability assessment analysis, it's usually just two boxes in the MITRE attack technique matrix where you're doing unauthenticated scanning in an environment, right? So there's a number of tools available to automate this. We just shared with you Atomic Red Team, which is a very, very, very good tool to use. There's other tools like Caldera, which, by the way, Caldera, on the day of this particular recording, they had a critical vulnerability. Like, you can exploit a system that's running Caldera. So be warned, if you try to play with Caldera, you might run into some issues with some security vulnerabilities associated with Caldera. So yeah, that's bad. And for the record, that happens in all software everywhere because it's all written by humans. It'll be much better, everybody. It'll be much better once AI is writing all of our code for us. That's wonderful. Now, one of the cool things about Caldera is it's by MITRE, right? So if you're looking for something that actually does that mapping of the MITRE attack technique matrix, and you're tying that together, Caldera is an excellent tool for you to be able to do that. The other thing that's cool about Caldera is you can install it on multiple systems and it can test post-exploitation lateral movement techniques amongst the different systems that are running in that environment as well. So check out that tool. The one we just did a lab on is Atomic Red Team. And you can see the power of Atomic Red Team and how we can go through and actually emulate and simulate a wide variety of different techniques that you can run post-exploitation on a computer system to do persistence or privilege escalation on that computer system. And this is by the fine folks at Red Canary. I love what they're doing, and I love that they're sharing this stuff. It's currently one of the managers of that project is a good friend of mine, Phil Hagen. I was an instructor with him for a number of years, and I just think it's fantastic that he's part of that team. Also, for the record, I have a really soft spot in my heart for any company that's giving away free and open source tools to the community. I've said it before, you got to be looking for the different vendors who has their hands out to give and who has their hands out to take, right? If you're looking at companies like Huntress, they have their hands out to give, right? Their Huntress Neighborhood Watch program is phenomenal. If you look at companies like Red Team or Red Canary, they have the Atomic Red Team. They have their hands out to give. At BHIS, we have a shirt we're going to redo called Proudly Sucking at Capitalism on the front of it. And on the back, it lists all of our free and open source tools that we share with the community. You can always tell the quality of a company by what they share with the community writ large. And these guys are awesome with that. The other thing that I really like about Atomic Red Team is it has a really good description of what the technique is and an explanation of what that technique will find and what it should do, right? So upon execution, calc.exe will be launched, right? I always love it. One of the things that attackers do anytime they're writing a new exploit is they try to pop calc.exe, right? It's one of their favorite things. We're going to pop a calculator because that shows that we have code execution and it's an easy thing to write. You know, just write it and boom, pops a calculator. And one of the great memes that I saw is if hackers were so good at math, why do they constantly need a calculator on their system? Which I thought kind of an inside joke, but I think it's funny out there as well. So very cool stuff. Now, from what we just did, and I kind of flipped the order of things around a little bit because I'm testing something out. What we just did, do you guys feel comfortable running that? Think about this. Like, if you're running something like Atomic Red Team, there's some people that get uncomfortable. But I've noticed that when people have their chance to actually use something, that fear is reduced. And that's really what I hope has happened with you running Atomic Red Team. You realized it's not a scary thing, right? It's just running a whole bunch of different scripts and it's going to test your EDR. It is not some type of, Skynet artificial intelligence tool that's going to escape. And what is the quote from Bender and Futurama? We want to get together and kill all humans. It's not going to work that way. It's going to run specifically in the area on the system that you have installed. And I think that that's important. We shouldn't be uncomfortable with running these tools in our environment. Now, some people will bring up tools like Bloodhound, and I think Bloodhound is a fantastic tool. It is also open source. The fine folks at SpectreOps are some of the people that kicked off this project, and they now have a commercial version of Bloodhound that I think is great. And the goal of Bloodhound is it'll run through and it'll attempt to identify all of the paths that exist from moving from a standard user workstation with standard user creds to enumerate all of the different paths that exist in Active Directory to elevate to a full domain administrator account on that environment, which is really cool. Now, it does a lot of different types of checks. And when we get to the Active Directory hardening section of this class, I think tonight or tomorrow morning, I'm going to create a couple of different labs where we're going to look at Plumhound output. And we're also going to be playing around with another tool called Ping Castle, which we'll talk about tomorrow on there as well. Now, one of the traps of working with threat emulation and threat simulation in environments is you get into a situation where people try to write their signatures that are too specific. So let me back up a couple of slides to right here. Now, one of the problems I've seen with people trying to write signatures in their SIM and in their EDR is they try to write a signature to match, let's say, I think you guys can see my cursor, my massive cursor here. You can see this command right here where it says regserve32/s/u. We're going to invoke something from a remote file. You can actually put an HTTP link in here for .set file. .set files are usually, it's basically XML version 1. And in this, it's using WScript object to fire off. It's not using an ActiveX control to invoke WScript object to run a command of your choosing on that .set file. And you have to load in script object DLL for it to run properly. So if we were going to write a signature for this, I have seen organizations that have literally created this exact string in their SIM and in their EDR. So the attacker has to run this exact command where it's executing from the Atomic Red Team Atomic's T1117 directory for the detect to actually fire properly. And that really gets into the gist of why we're doing a lot of these pay what you can classes and trying to spread the love and spread the knowledge as much as we possibly can. We get into problems where people say, you're teaching us stuff from the Windows command prompt, you're teaching us stuff from the Linux command prompt, and really I don't need my analysts to know Windows command prompt. I need them to understand how to use our EDR product. And that makes me sad. Right? That makes me very, very, very sad because if people do not understand how threat actors work, if they do not understand how different attacks actually work, you end up with analysts writing signatures that are very specific to this, right? They're going to write the Atomic Red Team, Atomics directory, the whole thing. And it's not because they're dumb, it's just because they're ignorant. And I mean that in the best possible way. Ignorant means you're just unaware, right? You don't understand what you're doing. Let me give you an example because I know that there's people out there that get offended whenever I say people are ignorant. Everybody has some level of ignorance, right? I'll give you an example. When I started in computer security back in 1999, 2000 timeframe in my professional career at Anderson Consulting and Accenture, I was hired by the Department of Interior to work in a actually the world's largest class action lawsuit. And I was in charge of securing a very large section of the Department of Interior. It wasn't completely me. I had other people on the team, some amazing people. But as part of doing that, they said, we want you to scan all of the IP addresses for vulnerabilities. So I didn't know anything. I was ignorant, not like bad ignorant, like I don't want to know that book learning, I think universities are a scam. Which they probably are, but at any rate. But when we were setting up the IP ranges, I set up the IP ranges to go from 0.0.0.0.0 to 255.255.255.255. And I proceeded to scan the entire internet. All of it. I think the name of the tool was Cisco's Net Sonar product. It was a long time ago. I can't remember. But I made a mistake, right? That was an ignorant mistake at that point. Yeah. Did John invent Shodan? No, I didn't because I didn't know what I was doing. And I had to sit down and I had to have somebody take the hammer away from me, the monkey, and say, look, dude, you have to know like what is an internal non-routable IP address, what is on the external, and what are different ranges. And I learned, right? But I had to understand the fundamentals of networking. I had to understand net masks. I had to understand network ranges. I had to understand IPv4 for me to be effective in my job. So whenever I say somebody's ignorant and you see something like what was just up on the slide, it is really within the realm of possibility that someone is going to just take that entire string and try to create a signature for it. Whereas the best thing that we can do is sit down with the analyst, train them in Windows command line, train them in understanding how attacks work, and train them that what you should be looking for is regserve32 being invoked, number one. Number two, is it being invoked with the flags /I? Number three, is it invoking a .set file? Number four, is it invoking script object DLL? If it is, then we're at the point where we probably want to generate an alert. We aren't going to get hung up on the Atomic Red Team Atomics T1117 directory. We're instead going to focus on what are the key components of this attack and how it actually works, right? So that becomes critical for us to understand how we're going to deal with those things. And we don't want to write those signatures to look for that highly specific attack. But how do we detect that attack in kind of a meta way on that as well? All right. So there's a lot of commercial offerings that are out there from Attack IQ, XM Cyber, Scythe. I recommend looking at these products and learning about these products. And I'm not going to mention, I don't want to mention a specific vendor. All right. I got a little mad last week. I got a little mad. I was at a conference and there was a vendor that had some attack surface management stuff that I was talking to. And I got to looking at what their commercial tool was doing, and they were running tools like Crackmap Exec. They were running tools like Mail Sniper. They were running tools for the cloud. A lot of the tools would be like Graph Runner. And I knew because I could look at the output of these tools that they were running a large collection of open source tools as part of their commercial tool offering. Now, they weren't necessarily hiding that. But at the exact same time, I know that this vendor that had something like, I think they had something like 50, $60 million of VC funding that they hadn't given a dime to the open source vendors of the tools that they were using underneath the hood. And almost this entire tool was nothing but open source tools, executing open source tools, wrapping them in a fancy GUI and generating fancy output. They were doing link local multicast name resolution attacks, and they were running those with Responder. They were using Crackmap Exec. They were using NTLM RelayX. They were using things like the Graph Runner tool that Bo Bullock wrote. And once again, I know for a fact that they did not pay any of the open source vendors anything, and they had millions and millions and millions of dollars. Now, is that legal? Yes, it is, because most of the tools that are out there on GitHub are released open source. It's free and open source. Many times it's GPL'd in such a way that you can use the open source tool, but you have to give credit that you're using that open source tool. So yeah, that may be legal. It may be within the license, but I'm going to tell you right now, it's garbage. We have a lot of vendors out there that are doing that. There are some good vendors out there. There are some bad vendors out there. I strongly encourage you, when you're working with these different vendors, ask them if you're using open source tools, and then further ask them, are you actually supporting these open source projects. One of the things that we set out in Antisyphon, and we did at the very beginning, very beginning, is when we teach paid classes, all of the instructors choose an open source project, and they can also use EFF or something like that. They choose an open source project that 10% of the total proceeds for the class go to that open source project that we use in that class. Because I have worked for training organizations that charge thousands of dollars for classes and teach people all of these open source tools, and those training organizations don't give a damn dime back to any of these open source projects that they're making money on teaching people how to use these tools. So yes, this is absolutely a little bit of a rant. It is. But when we're talking about security and we're trying to make things better, we have to make things better. And we do that by giving back. Once again, I want you to constantly look at who has their hands out to give and who has their hands out to take. And you're going to find out who are the people that you want to party with in your career. All right. So we already did this lab, the Atomic Red Team and Bluespawn lab. I thought it fit better because it sets people have the capability to be able to do this. So we're going to move on to host firewalls, and then we're going to get to a lab. All right, so this is an amazing technique that shuts down a tremendous amount of the lateral movement section of the MITRE attack technique matrix. So if you're looking at it, we have this entire column is lateral movement, right? Most of the organizations that you encounter today, they have, it's really sad, their workstations, as soon as they're in the Active Directory environment, we got the F is for family, father, just basically taking those pants off, chilling out, airing out, no protections. They're just wide open. And as a pen testing company, I want you to know that we actively take advantage of that in moving laterally across an environment. And it becomes really super easy for us to move laterally because there is zero protection post-exploitation. This is absolutely one of those things, if you're in a hot nation state on nation state level activity, if we get into an environment and they have the host-based firewalls that are enabled, we almost always back out very quickly. Because when we're talking about defense in depth, every single host in that entire environment is now an absolute detection opportunity for the adversary. So if we look at segmentation, the number of post-exploitation attacks that exist in here, they go all the way back to 1997, right? If we look at past the hash attacks, that is 1997, right? Past the ticket and security access token, if we're doing Kerberos level impersonation on the environment, that has worked since Active Directory existed because Kerberos tokens have been a thing. We need to make the assumption that you are going to get compromised. This is something that I keep pushing in every security class that I teach. You are going to get hacked. And in many ways, you have to be okay with that. Just wait, I got a coffee. All right. And we're back. All right. So you are going to get compromised. And what's really hard for people to get in their heads is this is acceptable. It has to be. You have to come to grips that you are going to be compromised at some point, and you need to build your architecture and your structure accordingly. What is unacceptable is an attacker dwelling for months, right? What is unacceptable is an attacker pivoting from one compromised system to the rest of the environment in a matter of minutes in your environment, right? That is unacceptable. Those two things are absolutely unacceptable in your environment today. Now, when we're going down this, we're talking about acceptability and saying you're going to get compromised. It's a lot like structural engineering, and I'll talk about that more here in just a little bit. But you don't make your structures completely rigid. You make it so they can move with the wind. You make them so they can handle an earthquake. You build them with that level of structural integrity and resiliency that they can handle those different threats that can actually hit your environment. Now, there are things you can do. One of the examples, and I don't have any switches on me right now. I don't think I have any switches. No, I have no switches. And when you're looking at a switch, let's say I've got a big switch that has, 50 different ports in it. Whenever a system that's plugged into that switch is trying to talk to another system that's plugged into that switch, that is a layer 2 communication on that system. So we have one system talking with another computer system that's going to be adjudicated by the switch. There's going to be an ARP request. Who has this particular MAC address? Please tell. And then the system's going to respond back that this MAC address is at this IP address. And then they'll open up a connection. That whole communication is going to stay on that switch. We can utilize things like private VLANs, which those systems are still on that network range. But if we try to talk from one host to another host, it is no longer adjudicated by the switch itself. It's now adjudicated by the layer 3 device, which is the router. If the router or the firewall doesn't have a rule that explicitly allows two systems to talk to each other, it's not going to allow it to occur. So your systems can all stand up on the same VLAN, but if they try to talk to each other, it's going to shut down that communication at the switch level at layer 2. What does this do, right? Host-based firewalls using private VLANs. What does this do, and what does it look like from a mental model when an attacker is trying to break into your environment? Let's say we have an attacker and a compromised computer system. Just your everyday, ordinary, average exploit. I get your system because they clicked on a link, right? Now, once I get on a network, there's a whole bunch of different protocols that I can use, like PSExec, pass the token, rdesktop, and pass the hash, where I can log in directly into all of the other computer systems in that environment, utilizing the exact same types of protocols that are used every day. And I can dump clear text passwords if I get local administrator with tools like Mimikatz from Kiwi or Gentle Kiwi, where I can dump clear text what the password is for that user. And if I'm logging into a system that has remote desktop open, the odds of me actually being detected are incredibly low in that particular scenario, right? So this makes it easy to move laterally in that environment. So I can move to a whole bunch of other computer systems, and then I can find a way to get to the domain administrator. Now, if this particular scenario looks a lot like Bloodhound and that graph that I showed you, it just so happens that it's basically showing the exact same conceptual framework. With Bloodhound, it'll identify systems that have our desktop enabled. It'll identify the systems that it can move laterally to. It can look at the group membership on the local system to try to find a system where domain users are in the local administrators group. You have all of these different things that you can actually detect as well. So, number of ways to deal with this particular attack. One of the best ways, turn on the host firewalls. We can do the private VLAN, we can do that, but with our host-based firewalls, we need to treat the internal network as hostile because that internal network is in fact hostile. Set up your internal systems so they treat the network with the level of trust that they would if they were at a coffee shop, right? All inbound traffic should be blocked and alerts should be generated, except from admin level jump hosts. If you have help desk, you have administrators, you're going to have jump hosts that you can whitelist or allow list to allow those systems to connect into your desktops. You're also going to have to create rules that the domain controller, backup servers, some core infrastructure servers can talk to the desktops as well. But you can push those rules out via group policy, or you can actually push those rules out through the built-in EDR product on the system as well. This is really going into the whole concept of zero trust. And I get very angry about zero trust because I have met no less than 5 people that say that they have invented zero trust. They're like, oh, zero trust was my idea. I came up with it. It's like, good for you. When I have them try to describe it, they all have their own convoluted way. You know, it's like, well, zero trust is a new paradigm that's in the back of the shadow of the minds of your children while they're sleeping, and I'm there waiting for them. Because if you look in the dark place, in that place you choose not to go, you will find me staring back at you. Ha! I'm the Kiswak Haderach, right? Right. Whatever. You run into these people all the time in IT. I was doing object-oriented coding before it existed. It's just like those people are a-holes, don't party with them. But the core concept of zero trust is you're not creating a trust relationship that is, you're trusting the network, you're trusting the domain, you're trusting the other systems. You're literally trusting nothing. You're not trusting the network. You have to authenticate to every single service that you access in the cloud. And that is probably the quickest way to look at zero trust, right? So we want to make sure that we're kind of using this base concept of zero trust where the network is not trustworthy. You should never allow SMB traffic between the workstations in your environment. There's nothing good that'll ever come back from that, ever. A lot of AV products have firewalls that you can enable and you can centrally manage from the console of that AV vendor. Once again, private VLANs can work pretty solid as well. So we had a test that we did, very similar to what you see on the screen, where we were hired to do an internal vulnerability assessment and an internal pen test. And every single workstation in the environment, every single workstation in the environment had their own firewall that was enabled. I think at the time it was McAfee. I can't remember. What did McAfee change their name to? They changed their name to something else, and not that it's relevant. I don't know if they'll exist that much longer, but at that time it was McAfee, right? And honestly, we don't even see Symantec and McAfee all that much anymore. It's pretty much CrowdStrike, Windows Defender, SentinelOne. We're seeing less and less Cylance out there. But at any rate, and we started up a scan of this internal environment as we were hired to do by our customer. They were like, go in, do an internal vulnerability scan. And we scanned this entire environment out there. We hit all of these systems that had their host-based firewalls enabled, and every single user in the environment got up and popped an alert that there was an active scanning attack, and all the users completely freaked out. So one of the things about, McAfee, it was named after John McAfee, and I did actually get the opportunity to meet John McAfee. He was at DEF CON and Black Hat a number of years ago before he passed away. And he was very nice. He was incredibly gracious. He was insane. Like, it's that song, The Piano Man. It feels like there's some place that he'd rather be. And I'm pretty sure that he wanted to be doing a big pile of cocaine or bath salts. I don't know. But he was nice. I was able to talk to him about AV, and we were talking about the state of AV and things like that. And he had some really, really super cool views on it. And one of the things he said was, he kind of regrets. He believes fundamentally that he invented antivirus, and he was very frustrated with the fact that it never really evolved beyond what he wanted it to do. So that was kind of crazy. I also at one point met Kevin Mitnick before he passed away. This is getting hard. Like Dan Kaminsky, Kevin Mitnick, Barnaby Jack, all these people. There's a lot of people that have passed away. And Kevin Mitnick was a lot of fun. And I know that some people don't like Kevin Mitnick. I get that, but I'm telling you my personal story with Kevin Mitnick. I used to teach at SANS, and we would talk about IP prediction attacks where you could jump in on a computer system, and that was the attack that Kevin Mitnick used against Satomu Shimomura, who wrote the book "Take Down the Pursuit and Capture of Kevin Mitnick." And I would always make this joke, and I would say, if you can get a copy of this signed by Satomu Shimomura, I will pay you like $10 for this. If you get a copy of this signed by Kevin Mitnick, I will pay you $500. And I was at one of the early Derby cons where Kevin Mitnick was there. And I just got off stage and was talking to a bunch of people. And this dude comes up to me wearing a Def Leppard shirt. And he has a copy of the book signed by Kevin Mitnick. And it turns out it was Kevin Mitnick who did that for me. And it sucks because I lost that book. I moved a number of times, but that was one of my valued possessions. And the other thing I loved about Kevin Mitnick was he would sit and he would talk to his fans, like without loss of enthusiasm, without loss of joy, for like hours. And I really like that about him. Now, like I said, people have opinions about him and, maybe his religion and things like that. But I'm telling you, person to person, one-on-one, he was great and he was gracious to people. So going back to McAfee and talking about firewalls, one of the things that McAfee talked about was moving away from traditional AV. And I think, what was it, Zone Alarm? There was some firewall that he invested in early in the stages, because he thought a really good idea was monitoring network connections coming in and network connections going out. And he wanted to see the AV industry start moving into that direction because it works to stop these types of lateral movement attacks. So ultimately, this goes back to the concept that I seeded a little while ago. We're talking about like architectures, right? Architecture is all about failure. And my wife is a structural engineer and she doesn't like it when I talk about this, but I really like structural engineering. Like we used to get magazines and I would look at her books like Load Factor Resistance Design and AASHTO standards and get these magazines talking about how structures work and how they should work and all of those different things. And it's great. It's awesome. But I realized by reading her books that everything about structural engineering is about failure. Everything. They know the failure for every single beam. They know the failure for every single truss. They know the failure for a door. They know the failure for a window. How much weight can it take? What's the lateral movement in an earthquake that it can take? It's all based on understanding the failure of every single component that they use as part of their architectures, and then designing the architecture in such a way that it is resilient to the failures of the individual components. Now, there are absolutely components in some buildings, like major columns, that if it goes down, taking the whole building, but they over-engineer those things, so the likelihood of that catastrophic failure is very low. And I want you to take that structural engineer idea, and I want you to think about structural engineering from the ages, right? We go back to Ugg and Thug. They were building mud huts, right? Somebody could walk by, kick a mud hut, and it knocks over, right? And then somebody's like, oh, geez. And then they're going to make it out of, it becomes like the Three Little Pigs, We're going to make it out of sticks, and then we're going to make it out of stone, and then we're going to make it out of, iron, and then we're going to refine the steel. And they keep trying to come up with these things, become more and more resilient to Mother Nature and different things that can happen that can lead to a catastrophic collapse of that building. And I really feel like if we're looking at IT architectures, we're barely entering the equivalent of the Middle Ages for like Gothic architecture, right? Like we do a lot of architecture through brute force and a little bit of engineering at that point. And I think the way that we progress in the world of computer security is understanding that that failure occurs. So when we're looking at, once again, that overlapping field of visibility, we're looking at knowing and understanding that any one of these security support structures can and will fail at some point, right? If we're looking at AV, it's going to get bypassed. If we look at network security monitoring, it's going to get bypassed. UEBA is going to get bypassed. SIM is going to get bypassed. But it's going to be incredibly unlikely that all of these things will be bypassed in an environment. That's what we've got to look for. And that's what we've got to hope for as we're progressing in this industry, as we're growing as individuals. And that also is one of the big things why we're pushing so hard for the pay what you can training, right? Because you can't run an NSM product if you don't understand packets. You can't run UEBA if you don't understand logs, and SIM if you don't understand logs. You cannot effectively run an AV EDR product if you don't understand what the attacks are and the ability to actually test that particular product. Because if you boil it back to the engineering analogy, pen testers, hackers, all of these different people are truly the structural engineers of IT, right? You have people that are doing development, you have people that are doing ops, you have people that are doing all of these things, but it's up to us and it's incumbent upon us as IT security professionals to be looking at the structural integrity of our IT assets. And that's really what this whole entire section is all about. So you have some firewall options that are available. NetSH ADV firewall set all profile state on. It's awful. This firewall is bad. Like the logging in the Microsoft firewall is horrific. Quite possibly it's one of the worst things that Microsoft has done. And boy, that's really saying something. That's truly saying something. Turn it on. It's far better than nothing at all. It is. Like the Ned Flanders, like nothing at all, like nothing at all. It's far better than nothing at all, and it will absolutely frustrate even the most advanced nation state level adversaries trying to break into your environment. And the advantage is you can push it out through a group policy configuration setting. But I mentioned this earlier, you also have all the different vendors that are out there have the capability of enabling and configuring the firewall from a centrally managed cloud solution. So we need to be looking at that. We need to be understanding like what are the tools at our disposal that allow us to do this type of configuration easily from the cloud. All right, so now we have a lab. We're going to play around with host-based firewalls and Nmap. Here we go. And this will be our last lab of the day. So I am going to kill my VM. I'm going to destroy my lab. What's the joke? Kill your television, right? Not that anybody watches television anymore. All right, so we're going to go to host firewalls and Nmap. So we're first going to get our Windows IP address. We're going to become root, and then we're going to scan our Windows computer system, and we're going to see what are the ports that are open. Then we're going to turn on the firewall and we're going to rescan the system to see what ports are actually running. Then we're going to turn it off on the system. Then we're going to play around with, like how we can actually shut this off and basically mount and attach to another system. We're going to use Kali with the firewall off. We're going to run a different module for Metasploit. In this particular module, we're going to use PSExec. And for the record, PSExec is the most commonly used exploitation tool in the Metasploit framework by far. You're going to set your R host, set the L host, set SMB user, set the pass, and then you're going to exploit dump password hashes on your computer system. Then you're going to shut off your firewall, or sorry, turn on your firewall, and then you're going to try to rerun the attack, and you're going to see how it gets shut down. So this lab is going to take us through the break, and let's just resume at 30. Let's resume in 35 minutes. So set the clock for 35. Let's get rolling, and then I'll do the walkthrough, or I might just do the walkthrough tomorrow morning, and we'll just go straight into the Ask Me Anything. So get those questions jotted down. I'll see you on the other side, everybody. And it is now full on Ask Me Anything. So we got a question right here from Fitzer. Out of all the tools you've mentioned, home lab use, which one is suitable for Raspberry Pi? What's the Lotus model of Pi that should be used? I can't answer that question, but the one that I have the most fun with is running AC Hunter on a Raspberry Pi. I think that that's probably the coolest you can do with that as well. Since you said that NetSH is garbage, what are your thoughts on UFW? Pretty solid. I think it's fine. It's just, even NetSH for all of its problems is still really good compared to not running one on that as well. Are we getting overlapped audio? I don't know. I don't know who's on with me right now.
I'm not.
You're not getting overlapped audio? Okay. So, all right. Just have you tried turning it off and on again? That seems to help as well. All right. So what else do we have? What else do we have for questions? AC Hunter is available. We have a webcast on installing Rita on the Raspberry Pi as well. B-sides, calc. Oh, it just went away. Just like that. It's just gone. Just gone. Where'd it go? B-sides, Calgary conference. Thank you to BHIS and your team for generous support. Happy to help. One of these days, I've got to get up to Calgary. If you'll still have me in Canada. We miss you guys. We like you. Sorry about that. What's the next best course for response now that we've pretty much did detection stuff? Patterson Cake has a really good series of workshops and classes as well. So be sure to check that out as well. You should look at that as well. Is it common to use SYSMON in 365 tenants and the for endpoint and detection? Whoa, apparently my system's just decided that C is the key that it's going to run. Okay, it's cleaning that out. There we go. All right, there we go. I don't know what just happened. It's just got really, really, really weird. Any commentary on Silk? I think it's fine. I don't know. I just haven't used it that much, so I don't have much of a recommendation on it, on that as well. There we go. What other questions do you all have? No, we got a lot of people typing now. Any AV that you can recommend that can scan large files, a couple hundred gigabytes to a terabyte? No. Most antivirus engines won't even bother unless it's an archive and it can kind of scan through the file names within the archive. In fact, that's one of the tricks for getting around a lot of the next gen EDRs is they basically ignore large files because they have to load that whole thing up into the buffer and do analysis on it. So instead, what most of the like current generation EDRs do is they don't scan the file. When the file executes, they monitor what that file does at the kernel level. And that's probably the best way to actually go about doing that. So whenever you're running a next gen EDR and running those different things, that basically is the cleanest way to do it. Don't try to scan the file and don't try to do analysis on all of the attributes of the file and the hash of the file. Just look at what that file is executing, and that's a better way to do it. So any of the modern AVs will do protections on those large files when they're executing. And if they try to do something weird with the kernel, they're going to jump in and they're going to freak out at that particular point as well. Is it common to utilize SYSMON in 365 tenants that use Defender, Endpoint, and Sentinel? Yes, you can actually set that up, but actually, let me back up. Yes, that's a good question. No. Usually whenever you're running Sentinel and you're running Defender, you're not going to be running SYSMON because a lot of the telemetry that you're getting out of SYSMON is automatically incorporated in Defender whenever it's logging up into Sentinel. So in those situations, because Defender is pulling the exact same telemetry as a SYSMON, I usually don't see a lot of organizations running both Defender and SYSMON at the exact same point as well. Have you experienced enabling app blocker defaults, break updates that use trusted platform module or use home folders for temporary files? Haven't ran into issues with that. But if you're looking at it, instead of, okay, so anytime you're doing any type of application allow listing, they usually are doing something called inheritance. And what that means is whenever an update process executes from one of the authorized directories, like in the Windows directory or the program files directory, if the initial program is trusted, the child processes will be trusted as well. So if the main parent process is allowed to execute and it spawns off other things, those will also inherit the permissions of the child process. Always, always, always coming back to, you want to test and validate this in production as much as possible. So look at that as well. All right. There was a specific SysMon config for running Olaf with Defender. Yep. But once again, that's at the GitHub repository for SysMon modular. So check that out too. What other questions? Good questions today. Can you set up app blocker to alert only from testing? You get events if something would have been blocked. Pretty sure you can. Let me check. We can actually go right into it. We can try to create a rule real quick. I have to restart it. I've never done it that way. Go ahead and start that and we can play with it as well. You can. I was answering this question. All right, cool. Well, if you can answer it, I've never done it that way. It seems like a good way to actually test it, not necessarily from the directory perspective like we learned in the class, but when you're generating the default rule configs, you can do that as well. So we'll go through that here in a second. So it sounds like you can. It's just not something I've ever done. I know that that's kind of the key thing that you want to do when you're testing your EDR. You want to make sure that your EDR is in alerting non-blocking mode whenever you're testing with Atomic Red Team, specifically from the directory where Atomic Red Team executes from. Because most of the time, it's just going to shut down the initial PowerShell execution of Atomic Red Team, and that's not what we're doing. That PowerShell execution harness is the execution harness for all of the other things that it's invoking. So do be careful with that. So I have a little bit, I have 105 seconds on that. But yeah, Code Brew said, yes, you can. So I trust that. Now, whenever you're talking about Wild West Hacking Fest going to New Zealand or Europe, the thing that I always tell everybody is remember, anywhere you're at in the world, you're always west from somewhere. So keep that in mind. Have you had much experience going up against third-party app blockers like TL? Any specific gotchas to watch out for from the blue team side? No, nothing off. Nothing. I mean, we see that all the time in our pen tests where you have a lot of the tools. And just to be honest, a lot of the EDR's strongest like aspects is not in the fact that they're using artificial intelligence and machine learning. Instead, what you're actually looking at in like Threat Locker and Carbon Black and Cylance and CrowdStrike is the strongest feature that they have is that application allow listing functionality. So yeah, we deal with that all the time when we're bypassing those products. And there's a number of different techniques. A lot of them will hooked into AMSI. A lot of them have certain directories they're just going to ignore that are automatically allowed. So yes, we deal with that all the time in what we're doing. I've been looking for cybersecurity groups, meetups locally, but how do we go about starting one? Honestly, Jelly Bean Stirrers, if you look at the like DEF CON groups, you do DC and then your area code, and you just check to see if there's a DC in your area code or if it's defunct. and then just start that one up. That would be a good one to start with that as well. The other thing is find your local FBI office and ask them if they would be interested in kicking out an InfraGard chapter as well. All right. Do you have any tips for bypassing WAFs? Adrian, honestly, it's barely an inconvenience in most situations. It's not, web application firewalls were a big thing. People were trying to enable them. And I think they're just a pain in the ass. And a lot of people don't actually turn them on. So that's one problem. But usually whenever you're trying to bypass a web application firewall, one of the things that you can do is you can look at the coverage of the application. So usually when we're bypassing web application firewalls, we find a part of the application that's relatively new functionality that isn't actually protected by the core implementation of that web application firewall. If you're throwing like straight up cross-site scripting, SQL injection attacks, yeah, you're going to light that WAF up. And we'll talk about that more tomorrow. But if you actually start testing business logic errors, like trying to do forced browsing to different directories from a user ID, web application firewalls aren't good at that. They really just are not that good at dealing with that. Also, OWASP has some really good encoding and bypass techniques. If you do like OWASP bypass techniques, you can look at a bunch of those as well. It's a full GitHub repository. You can look at all of those. What are some gotchas on app blockers config errors that let you get past them to watch out for? So there are a number of different ways to get around it. So when we're setting up app blocker specifically for the directory, it's really, really helpful for that initial code execution where code is executing from the downloads we're trying to stop it from executing from downloads, desktop, and documents files. However, it will not stop code execution for exploits of applications. So if you have a third-party application like an exploit in Adobe Acrobat, going back to that exploit, like that kind of like permissions inheritance. If I exploit Adobe or if I exploit, Java or something on your system and it is trusted, then my malware is going to be trusted. So there's absolutely bypasses when you're doing it that way, but we're trying to make it like very quick and easy and stopping a large number of attacks. We're trying to use that Pareto principle as much as we possibly can, and it's 100% true. So if we can get into initial execution from an exploit of a trusted app, then you're going to be ready to go on that as well. All right, so people are talking about Kali Purple. There you go. Web
Do you
application
have thoughts
firewall
on that?
bypass.
Yeah,
What's
it
up?
looked like they asked if you had any thoughts on that Cali Purple.
I haven't used Kali Purple on
Okay.
anything really. I've just been using straight Kali and installing the packages that we need. BHIS uses a default Kali instance and we upgrade it with a whole bunch of other tools that we've written and SSH keys and also monitoring on the systems as well. What's your take on using LLMs when trying to solve a cyber range challenge? Use them. I mean, it's a tool. HK, it's absolutely a tool. And I don't want to be one of those people that's like, you should never use ever any, LLM or artificial intelligence, because at that point you're just a Luddite, right? And whenever we're looking at like Luddites and we're looking at people that are going around and smashing looms, if we go back in time, you had a number of Luddites that were like, look, we got to smash looms because when looms come up, it's going to put a bunch of people out of business that are creating textiles. Turns out that was 100% true. There's all kinds of like crazy things whenever you're looking at the beginning of the industrial age. But yeah, the Luddites that were smashing looms, they were 100% correct of two things. One, the quality of the loom that it would produce was not as good as what a human could do at that time. That changed over time. And number two, it would put a bunch of people out of business, and it did. The worst possible example of this is India. The United Kingdom around the late 1800s, they basically passed, India was creating some of the finest textiles in the world, but it was all bespoke. It was all hand done. And there was nothing that they could do in the West that could compete with the quality of textiles. So when they went into India and they kind of took over India, they basically passed a law that people in India were not allowed to create finished goods. They could create raw materials, ship it to England. England would create the finished goods and then ship it back to India. And that whole thing wasn't just for textiles, but it was for foods as well. And that led to, I think, roughly 100 million people dying prematurely in India due to starvation and everything. My point on this is anytime that there's a new technological innovation, there's always people that say that they've got to fight it. And usually those people are correct, right? Whenever you had slide rules come out, there's people like slide rules are cheating. We need to do it by hand and we need to memorize these things. And they were right. When calculators came out, you run into a situation where people are like, well, now no one has to know math because they have these stupid calculators. And they were right. We didn't need as many engineers as we did before doing all this crap by hand. Then we come out with graphing calculators and same thing, hitting again. Now, if you're going into engineering exams, they can use TI-85s because this is a tool. And inevitably what happens anytime that there's a huge amount of technological innovation, whether it's textiles and Luddites and looms to calculators to computers to LLMs, is you have people that can embrace and utilize that technology to make them more efficient at what they are actually doing and they get good at it. Or you have the people that get stuck in the old ways and then they end up out of business, starving and dead, possibly. So we see that as a problem, right? So what you need to be doing is you need to be embracing and looking at how can you utilize this technology to enhance what you're doing, right? To get better at what you're doing. And years ago, years ago, we had like I'll give you an example. Whenever we used to run exploits, we would run Nmap, we would do banner grabbing, and even before that, we would run netcat, grab banners, look at the version, go to packet storm security, find an exploit that's written in C or Perl or Python, compile that code on our system, run the exploit against that computer system, and it was all very much by hand. Then they came out with vulnerability scanners. And people are like, that's cheating, that's crap. We do it by hand. We don't do it with the stupid scripts, kiddies, tools, and all of those hackers that had that attitude, they kind of went by the wayside, or they were basically just going to start using vulnerability scanners. The problem was the complexity associated with exploitation and computer security was exploding, and it still is exploding. So vulnerability scanners merely became a tool to allow us to deal with the scale of technology growth that we ran into in the early 2000s with tools like Satan, Sarah, Saint, and Nessus. And now we're entering that exact same space. So if you're looking at like red team and pen testing augmentation tools, and you're looking at AI, you're talking about all this stuff. These are tools that are designed to help deal with the massive exploitation, explosion of advanced technologies and having these technologies grow and really not getting rid of the older technologies. So we have all of the old technology problems and we have new technology problems. You're going to need additional tools in vulnerability scanning, pen testing augmentation. You're going to need tools like vulnerability analysis and LLMs to help you through that process as well. Is the ADHD VM updated? I'm done with the ADHD VM. I just use the Cloud Labs from now on. It's so much easier. Yeah, I love Eric's quote. Married to a math teacher, said that graphing calculators open her students' eyes to what those formulas really mean and what they actually do, right? And technology can really, really help you understand that. And that is just what we're ultimately looking for on that as well. Yep, all tech is built on top of old tech. Do you have any good North Dakotan jokes? Those used to be popular in Montana. Um, so the earliest incarnation of that I remember hearing this joke goes back to Ronald Reagan when he came to South Dakota, but quickly South Dakotans took it over. And they basically said, three North Dakotans came up to the car and they realized the keys were locked in the car and they didn't know what to do. So they started freaking out about the keys being locked in this car. And how are they going to deal with the keys being locked in this car? And as they were sitting there and they were stressing about it, one of the North Dakotans looked at the other and said, well, we better hurry up because it's about to rain and the sunroof's open. So that was a joke that, we co-opted. Ronald Reagan said it originally as liberals. So there you go. So that's one of the jokes. A lot of the other jokes, they just get bad. One of my favorite professors says AI is just a tool that other professors try to ban it and telling the students they don't trust them. Yeah. I don't know. I don't know if I trust AI more or less than I trust most human beings, right? I think that there has to be some validation of it, but I would validate what anybody would tell me anywhere. AI isn't going to take your job. Someone that knows how to use AI is going to take your job. I think that that's a great quote. I think that's a great quote. Nice. I'm going to give that a thumbs up. All right. All right, everybody. Really good section today. Tomorrow, I'm hoping to have a new lab, maybe two. I think I'm going to get at least one set up for you all. We're going to be using Ping Castle. So, and maybe Plumhound. I'm not sure. I might just do a walkthrough of that one as well. So I want to say thank you so much for attending. It was a lot of fun, and I will see you all bright and early tomorrow
Wait a
morning.
second, John.
Oh, wait,
We can't go
do we have our
yet.
bingo winners?
Yes, we got a bingo winner.
All right.
So- And you have to be here to win. So hopefully this person is
Listen
still
to
here.
win.
I think I saw them typing. It is neighbor. You have
Neighbor.
won. Yay, I see you typing. Okay.
There we go.
Yay.
Woo!
I will be sending you an email, a DM and getting your information. I also, before we end today, since I'm not going to be here tomorrow, we love all of our streaming folks, but we can't send you a cert of completion because we have no idea who you are. So if
That's a
you
good point.
register, we will send you a cert of completion, but you have to register in order to do that. And I will make sure to post another link in Discord. And again, congratulations, neighbor. And I hope you guys have a good class tomorrow. I will miss you all. But I'll be on Discord, so you can still bug me if you want.
You bet.
Thanks for letting me do that fun bingo stuff,
So,
John.
so happy. All right. And I'm going to miss you tomorrow. Talk to you later.
All right. Have a good evening, everybody. Go ahead,
Bye,
Megan.
everybody.
Other Megan. You can kill it with fire. Bye, everyone.